Hello everyone, welcome to day 13 of our machine learning internship. And in previous two sessions we are discussing about our pre-processing tool, which is feature selection, talking about feature scaling and then encoding, and then moving with handling null values and then outlier detection and handling. We have completed till now. So next what we are going to do is, that is what simple pre-processing, that is fine. So now the ultimate next step is going to be going with the algorithm. But before going there, we need to pass through some steps. One is mandatory, another one is optional. So we'll discuss what all those steps, and we'll discuss further. Talking about the steps in machine learning, collection is over. Now pre-processing elaborately is over. Going with the next step, before achieving this model selection and training, you have to pass a step which is train test split, where we have already discussed. We are going to split our data set into parts. One is for training purpose, another one is for testing. I'll tell you what it is. And after that, this is optional. Okay, feature selection is optional. Once you complete this, you can jump into model selection, training, prediction, evaluation. Or you can also go with this feature selection and then go here. So we will be selecting important features. So I'll tell you why or what and when we need to do it. What's the advantage of it in further. So talking about the train test split. So in machine learning, the train test split is a technique used to evaluate the performance of a predictive model. So they will be helpful in evaluation. They are not going to evaluate it, but they will be a key factor. Why? So the basic idea here is to split the available data into parts. So we are going to split it into two parts. One part is used for training the model, and other part is used for testing its performance. So previously we have discussed, right, we will be giving our algorithm the data, so it will learn. So now if I am having 1000 rows, I am going to split it into parts and give some part of it for training. Okay, so it will learn. So I need to know how much it has learned, right? So the remaining part I will be using for testing its performance. With that I can test and evaluate it, right? Talking about that, how are we going to split this? Usually this is how we will split it. I'll explain that. We will be using test size, which is 0.2. If it's 0.2, which means that we will be splitting the 20% of the data for testing. The remaining 80% will be for training. If the value is 0.3, then 30% of the data will go for testing and 70% will remain in training. And like that you can increase it. So 0.1 is 10%, 0.2 is 20%, and so on. So yeah, for example, I'll tell you the scenario. I'm having a data set, okay, which is around 1000 rows totally. So in this 1000 rows, if I pass it to this train test split, if I set it as 0.2, then randomly 200 data rows will be picked up and it will be given in the testing data, and the remaining 800 will be in the training data. So you understand, right? 1000, 0.2, which is 20%, 200 will be taken out. Like that, you can set 0.3, which means instead of 800, 200, it will be a 700, 300, randomly picked rows will be in your testing data. Fine. So to achieve this, we'll be taking from sklearn.model_selection. See here, now we are using model_selection, where we'll import train_test_split. Okay. So this is a module which will help you to split it into parts. And here we are going to create four variables. I'll show you when we see hands-on. Why is till now we done pre-processing, etc. But at that time itself, what we have done in the pre-processing itself, we have splitted our x and y. X commonly is the features. Y will be your single output, only one. It's a panda series, one column, right? So now you have x and y. So you need to create x_train. Usually you can give any four variable name, but commonly in the machine learning community they used to give x_train, x_test, y_train, y_test. So what will happen is, you are giving x and y, right? That particular value, so they should be in the same size. So for example, the first row of x will match with the first row of y. So what all index it is taking for testing, it will be taken in y also. So that will be splitted as x training value, okay, and x testing value. So if you have totally 1000 features, in that 800 features will be here and 200 features will be here. Talking about y, their respective answers are their testing part. 800 answers are target will be here and 200 target will be here. That's what x train, x test and y train, y test is. Imagine like this is what happening. I'll tell you, in school days we used to have exams, right? So we'll be studying for the whole semester and you will be having some questions, we'll be learning it. After that, in test, what we'll do? In test, in exams, they will be giving you questions only, not the answers. Now you understand, X train is your question for learning and Y train is the answer for your learning questions. These two. Okay, now you have question, you have answer, you will be giving these two alone to your algorithm. I'll show you how we will be doing it. X train and Y train alone, the training question and answers or the features and target will be given to the algorithm. Then once it has learned, we will be asking the model to answer these X test alone. So we won't be giving you the answer for this X test. We will be giving the X test alone to our algorithm. So it will give some answers. Okay. So for example, if this is 200 questions, then 200 answers or 200 target will be given based on what it has learned from the algorithm. Then now you have the answers from your algorithm and your original answer in Y test. And with those, you can compare with this evaluate and improvement. You will be evaluating with some packages from Sklearn and you can get a score and then you will improve it later. So that's how our machine learning task will be. And this is the important factor. And you need to pass your X, Y test size. These are mandatory. Talking about random state, random underscore state is optional. So what is this random status? Previously I have told you, right, when we actually split this, it is going to take a random 200 rows. If you go with 0.2 in the 1000, random 200 rows will be picked. So now for example, if you run this command once again, then what will happen is once again another random 200 will be picked, randomly 200 will be picked. So every time if you rerun it, the new data points will be taken actually. So if you want to have consistency in your code, which means if you try with the same data points, you are getting some output, some accuracy percentage, some evaluation. If you want to have the same when you try once again, then you need to take those particular 200 only. So for that, what you can do is whenever you are starting, you can set a random number here. So what this will do is it will go and take in that value, random state. So every time you rerun this, those same points, same manner, the data will be collected so that you can have consistency in your data. You also have other things like I'll tell you when to use stratify, etc. when you go with projects. These are optional parameters. So before going into the next one, I'll go and teach you the train test split. I'll connect it and upload some of the data sets. We'll start with import pandas as PD. And I'll upload for this we can take hard data set. Copy path and data equal to pd.read underscore csv. Data.head. This is our data, and now you need to select your features and the target separately and then scale your features and all we need to do, right? Here I am not going to scale because we are going to see the example of train test split, right? You know how to scale it and what will be the procedure, you can follow it. When we go for actual project, we'll follow every step and proceed with that. Now in X, I'll call data.drop. For now, we'll go without scaling or we don't need to encode anything here. Outliers, etc. are optional. It will improve your performance, model performance. Okay, target and axis will be 1, no in place, and Y will be data.target. And get the shape of it. Data.shape will be 1025 rows and 14 columns. X dot shape is going to give you 1025 rows and 13 columns. Y dot shape will be 1025 rows and only 1 column. Okay, so that's how we are having the shape. This is important because later when I show you the difference, then you can understand with this only. Okay, So moving to the next one, now we have features in X and target in Y, right? For example, if I have done in X, Y is same. In X, I need to go for scaling. Encoding is not necessary here. You can check the null value. I think this data set is fine. And also you need to check for outliers. You have handled everything. Everything is fine. Now in X, you have your features perfectly. And in Y, you have your target. So now before going into algorithm, you can go from sklearn.model_selection. You can import train_test_split. And for this, you need to create 4 variables, right? So I'll go with x_train, x_test, y_train, and y_test. Usually we used to call like this: x_train, x_test, y_train, y_test is equal to the module train test split, and I need to pass my x value, y value, then the test_size will be setting it to 0.2 now, and we'll call the random_state, and usually people set it as 0 or 42. You can go with any number. I told you, right, the significance of it. Every time you rerun this, same data will be collected from it, same in the same method. So now I'll print xtrain.shape, print ytrain.shape. Once again, what is train? Train means training data. X is features, Y is target, the training question and training answer shape. So you can see, right, we have splitted it into 0.2%. We have totally 1025. So nearly 820 rows has been selected for training randomly picked values. And you can check the shape of it. X is the features, those 13 columns are here. Y is their answer. For 820 rows, their question and feature is here. The answer and target is going to be here in Y train. That is the similar case when you go for testing also. If you go with x_test.shape, and if you print the ytest.shape, so we have 205 rows for the testing, which 13 columns as features and 1 is going to be your target. So this 2 you will be using for your algorithm training purpose, and you will be passing this alone to your algorithm for testing it, and then you will be getting some answers from your algorithm. That with that you can go and compare with this one in the evaluation part to evaluate your algorithm. So that is what the use of your train test split is. Before going into the next one, which is feature selection, as I told you, feature selection is optional, which means you can directly jump after a test split. If you have x train, x test, y train, y test, why waiting for? You can directly jump into your model. For example, I'll just take one model now and proceed with that. Okay, so yeah, here talking about that, the output is target, which is 0 or 1, which is classification problem under supervised learning. We'll learn furthermore about the algorithms. Don't worry now. What all I'm going to do next is just for introduction for you. You are just going to observe it, what is happening there. I'm not going to teach it now. That will be after feature selection. Okay, after that we'll be learning backend of algorithms and how to improve it, etc. So yeah, this is a classification problem actually, since the target is 0 or 1. So we need to take a classification algorithm. So yeah, from sklearn we can take algorithm. So this is actually a package where you can import an algorithm which is like logistic regression or any other algorithm. So logistic regression, even though the name is regression, it is used for classification. Okay, so I need to create an object for it, model equal to or algorithm equal to logistic regression. This is for classification. I'll teach you later. So now you have created a model. Fine. Now your next task, what in machine learning you will do is, you will call model to fit. This fitting is the place where your algorithm is going to learn. So it's the learning part, or machine learning is actually happening here. Machine is your algorithm and the learning purpose happening in the fit. And in fit, what should I pass for learning? the learning tools are going to be the X and Y value. X is features, okay, and Y is the target. See here they have given, and I need to pass X underscore train, comma Y underscore train. I'll run this. So this is now model is building on it, and they have learned from it. Okay, logistic regression have learned it. Ignore these, we'll see about it later. Once you've done that, what we'll be doing is, next step is prediction, right? Prediction or giving the test. So I need to call model.predict. So this is where I am going to give a test. Okay, or if you want a new prediction, you can give it here based on the learning. If you give those 13 columns, okay, it will give you for that particular row, it will be either 0 or 1. Instead of one row, I will pass the entire X underscore test, which is the testing questions alone. See here, now this is giving me an answer which is ones and zeros. Do you know what this is? If you check the length of this, it is 205. Do you remember this number, which is nothing but the length of Y test is? What is the length of that? 205. Okay, so it has given answers for your X test. For each row, it has given whether your value is 1 or 0 for that particular column, particular row, which means whether the patient is having heart disease or not. Based on that particular row detail, it has given. This is the prediction. I'll be loading it in a variable called as answer. And once I had this, what I'll be doing is, now I have a variable which is Y test and an answer variable. I need to compare this, and like a teacher does, I need to evaluate. For question 1, we are having 205 questions and 205 answers. You have the original answer and the answer by your student with your algorithm. So you need to evaluate for first row whether it's correct or not. 0, 0 matching, yes correct. 0, 1 wrong answer. So like that we will be evaluating. We can't do it one by one, right? We will be using from some of the metrics, which is the evaluation. I'll just show you. You can call metrics import accuracy underscore score, and the score is equal to, I'll call this accuracy score. So this is for classification purpose. You can pass, if you check the documentation, it will give you need to pass your original true Y true value and Y predicted value. So Y true value is Y test and the predicted value is answer. So now if I go with score and multiply, like it will be giving in the decimal points. If you multiply it with 100, and I can get that this algorithm is performing 78%, which means in the answers in 205, 78% answers is correct. Remaining thing came false. Okay, wrong answers. That's how we will be evaluating it, and then we will go back and change this algorithm or change our pre-processing techniques, etc. This is how our entire machine learning flow will be. This is a simple explanation or simple example. So instead of this 205 rows, you need to do some process with your data and pass a single row and call this predict option. So that will predict the answer and give you the output as 0 or 1 for that particular patient. So like that you can use it for prediction also. Fine. So till now is it okay? It is okay. So now we have X, we have Y, we have given it, split it into train and test, given it to our model, it has made some prediction and we got our answer. So moving into the next one, I told you, right, we went into model selection, model training has been done, prediction has been done, evaluation and improvement have been done. You have a lot of model, you need to learn, and you can go with that based on the task you are having, like classification or regression or clustering, etc. Fine. So before jumping here, now you know how we are performing it. You don't know the exact details, what all we can do, which we will be seeing later. Coming here into feature selection, this is an optional step. So what is feature selection? Talking about feature selection, it is the process of reducing the number of input variables when developing a predictive model. Okay, so we have features, right? So feature selection is selecting the important features. So it is desirable to reduce the number of input variables to both reduce the computational cost of modeling and also in the same time to improve the performance of the model and get rid of noise. See here in X we have only important columns, which is the medical details. But if you talk about our Titanic dataset, we have seen there actually it had a name column or a passenger ID column, the ticket number column, etc., which has nothing to do with the target or the outcome. So we will be dropping it when we select the X. Okay, if I found that age is not an important factor here, I need to drop it. So instead of entirely passing all the features to your algorithm, you can narrow down and pick important features alone. For example, if age and cholesterol value and the slope value and this value, these 4 columns are important. That is the deciding factor for the target. What I can do is I can leave the rest, and in X I can take those 4 alone. Now, how will you know what all the important features? And that can be done with the help of this feature selection. So that will help you to reduce your computational cost, which means every time it runs, the time, the energy, the computer, everything is spent, right? So that can be reduced, and it is important to reduce the noise and improve the performance of the model. For example, feature selection, if I want to tell you, it is like selecting the important chapters. So the student is learning here, and as a teacher you are giving, these are the important chapters. In that only I am going to ask questions. The answer will be based on this alone. Don't study the unwanted things, just focus on this one. Okay, so that is what feature selection is. So to select your features, you have some methods. So one is called as dropping constant features, another one is correlation method, then we have mutual information, then we have chi-square test, then we have ANOVA F value. We'll see one by one. So we'll start with the first method in our feature selection, which is going to be dropping constant features. So talking about the dropping constant feature, it is the process of dropping constant features which are actually not important for solving the actual problem. Which means that this feature which should be interlinked with your target, and also it should have some importance or any change which determines whether it's actually a feature or not. And this is the process of dropping features which are actually constant. Okay, imagine you are having a column which is constant everywhere. What is even the point of having it? Imagine a column or a feature which is having 1 in all the rows, okay, in that particular column. What is actually the process of it? What is even the point of having it? It is going to be same. If there is some change, then you can map it with your output. So this constant feature is like dropping the constant features which are actually not important for solving the problem, and it can be done with the help of variance threshold from Sklearn. And the variance threshold identifies features based on threshold value. So we can have a threshold value, so that based on that the output will be selected. So from now on we'll be using this get, support, etc., which I'll tell you. So later on, these are some of the basic methods which most often we won't use, variance threshold or the next few methods. The last 2 or 3, the talking about here, correlation, etc., we won't use much further. Mutual information or chi-square test or ANOVA F value are used very often, and we'll see that. So to achieve this variance threshold, you can use from sklearn.feature_selection, you can import variance threshold. And you have to create an object, and in that the threshold value you should give. For example, if the threshold is 0, which means that there is no change. For example, if 1 is there in all the places, then the threshold, the change there is 0. So you need to find those columns. You can go with that. You can go with 0.1 change, 0.2 change. Based on that, they used to decide to drop some columns. First, you have to fit it with your data, and then you have to get the support from that. So let us see what that get support is giving us. So coming here, data equal to pd.read_csv. So I'll pass heart.csv. Okay, data.head once again. So x equal to data.drop target. Okay, we need to pass axis 1. Fine. So x.head, I think we already had it, but still once again we'll refresh that. X.head, fine. So now in this, if I want to take, for example, I need to select some important one. So I'm going with from sklearn.feature_selection. This is from that. You can import variance threshold, and the variance is going to be variance threshold, and I'll pass a threshold value, so I'll set it to 0 now. So we'll go with variance dot fit. We'll go with the x value here, so that will be fitted now. So if you want to get your answers, you can go with it's variance, the object dot get underscore support, and that will give you, it's boolean, which is true, which means that everything is going to be true. Not like that, it is going to give you a filter which you can pass to your column names. You can pass this as your filter in x dot columns and take those particular columns alone, which means that here it is giving every column, which means that the variance is this condition, this what you are checking is failed, which means that everything is good with this variance of 0. You need to check for some other thing. If it is found, then it will give you false. You can see it is false in many places, which means that the change there is 1. Okay, so like that you can map and take only the columns which have, see here, important, so you can go with these columns and proceed further. So that's how variance threshold works. Mostly we won't use this. For example, I'm telling you. So the next one we are going to see is another method, which is correlation method, which also not that much used, but you can learn about it, and it may be useful in any part in your machine learning career. So talking about that, the idea behind this method is to remove all columns which are highly correlated. Okay, so why they are going with this is, imagine you are having 10 columns as a feature. For example, if 2-3 columns are interrelated, okay, but they are closely related. Correlation means how one column related, how one is related with the other, correlation between them. If one increase, other also increase, one decrease, other also decrease, the same trend. In the 10, if you have the 3 columns which are very correlated, they are somewhat similar, then what is the point of even having it? Because obviously they are going to support or give the same evaluation in your output. In such case, what you can do is, in that 3 you can take only 1 and leave the rest of those. So that's how it works. So in feature selection, using correlation, we can typically set a threshold for the correlation coefficient. So the correlation we can achieve from pandas, right? CORR. With that, we can actually select some of the important features. Like that, like if the columns are very correlated, if their correlation value is very near, then you can actually drop those columns. So that's how this correlation method works. To do that, we don't have a library. We need to manually go and achieve this. So what we'll be doing here is, I'll explain here. We have to store unique column names. We have a set, because set will store unique names. And in CORR, we are getting the correlation of that, your data set, right? So what we are using is, for I in range, we are getting the length of the columns in the correlation. So correlation table will be different, right? So it will be a table, and I am using another for loop for j in that range. So if you have 6 columns, okay, in your correlation, then in that 6, it is going to start from the 6th column. For example, if it is 6, then it will start from 0 till 5. So like that, if you have, you can go one by one, okay, each row and each value from that table can be taken, and that will be used here to check the correlation. Okay, so it will try to calculate or get the value using ilocate I comma j. So these two values I and j will help you to pick one by one values from your table, and I am getting the absolute value of that, which is a correlation value from that, right? So if it is greater than the threshold value, then I can add it in this set. So you can set a threshold value like 0.7. This 0.7 is a correlation value. For example, if I want to get the correlation, I'll go with data.corr. This is the correlation table, right? So what I'm doing is, I'm calculating this. So we can calculate 1, 2, 3, the length. So the total column length will be there, right? So for that, I'm going with a for loop, and I'm also creating another nested for loop. So it will go and take this value, then this value, then this value, like that. It can take all those values and see here, what is this correlation actually? 1 means it's actually the same, okay, highly correlated. If it is -1 means they are negatively highly correlated. Okay, negative correlation is high. If the value is around 0.7, which means they are highly correlated. 1 you cannot achieve it. If they are same column, then only you can achieve it. Otherwise, if you find a value, okay, if you pass it in a heat map, right? Do we have SNS here? Yeah, we haven't imported it. Import Seaborn as SNS. So the value, if it is above 0.5, then it defines that it is a positive correlation. If you find this color, they are positive correlated. Okay, these two columns are positively correlated. Like that, if the value you can set after 0.7 or 0.8, if you find that those columns there is no point in having, okay, because they are highly correlated. That's what this correlation method is suggesting. You can actually get those column names and drop them. So that is what you can achieve using this function which we are going to write. So you can write a function to go and achieve one by one. So I'll call define correlation. I'll be getting data and threshold, and my task is to create a column. Okay, it's a set, and correlation will be data.corr. So once I find the correlation for I in range, the length of your correlation.columns. Okay, with that, another for loop which is for j in range. So if you plot it, you can find it will go one by one and take all of these individual values from all the rows in all the columns. So in the range of I we need to go. So here we are selecting if the value from that, the value, if I am locating the x and y, which is I comma j, if the value, absolute value to get the full value is greater than the threshold, which defines they are highly correlated, then the column, correlation column, we can get a new name, column equal to correlation dot columns of I will be the column, row, j will be the row axis. So with that I can add here. Okay, so in list we'll appending it, here we'll adding it. In set we have seen, right? Finally after this I'll return correlation underscore column. Okay, so we can pass our data here, correlation, we can pass x comma value 0.8. so if they are greater than 0.8, if anything is found, it will be added to the set. It's not found, so like that you can go and find some columns. If they are correlated, if you find their names, then you can actually handle those by dropping it. Okay, so that's how this method works. So these two are we won't use much further. These are very base methods. It's not suggested to go with these. These three are very important. You can start with mutual information. What is mutual information? So it is a statistical measure, okay, that tells you how much two random variables are related to each other. So the value of mutual information will be 0 if the two variables are independent, and the value of mutual information will be higher with higher dependency. So mutual information is available for classifier as well as regressor. So till now what we have used is we have passed our entire data set directly, or entire features. From now on in mutual information or f underscore class f or ANOVA test or chi-square test, what we will be doing is we will be separating our x and y value. Okay, and our task is to pass our features and target separately. So what it will do is this mutual information classifier, for example, I'll tell you here, see this data set. We have our features and we have our y, which is target, right? So this mutual information or ANOVA F test or chi-square test, they will calculate this column how it is related with the target. Okay, like that mutual information classifier is going to calculate for age. It will calculate how age is deciding the target. It will fix a value. If there is no relation, the value will be 0. If there is a relation with higher relation, higher value will be given. For gender, for cholesterol, like that it is going to calculate the relation with y or the target. With that you can get a hierarchical table. So from that you can decide For example, if I want to select the first 5, which are 5 important values to decide the output, like that you can obtain. So that's what the idea behind this mutual information classifier. So from sklearn.feature_selection, you can import mutual_info_classif for classification problems. For regression, you can go with _regression. So mutual_info_classif, you need to pass your X train and Y train value. Remember, you need to go through this mutual information classifier or chi-square test or ANOVA test after splitting your train and test part. Then only you are supposed to go here. And what you can do is you can go and call mutual info classifier in this MI, and it will be giving you the results which you can get. You can convert it into a series, and then you can set the column names as index. So this is actually a quite complex thing. This will be really easy. First we'll see this and then move here. We'll be using a supportive tool which is select k best. First we'll go with this. Okay, I'll tell you practically. So we have our X train, X test, Y train, Y test, right? So from sklearn.feature_selection, import mutual_info_classif, and mutual information is equal to mutual info classif, and I need to pass my X train, Y train value. And the mutual information, if I print MI, you can see I'm getting a lot of numerical values, which if it's near to 0, then there is no relation. If it is, the value increases, their relation increases, right? So what I'm going to do is to convert it to a viewable format. I'm going to convert this as a series. Okay. So now if I print MI, what will be there? It will be a single column with index number 0, 1, 2, 3, etc. 12 columns. So 12 values are there. Just for our visual perception, I can go with mi.index. I can set the index as x_train.columns, right? So there's are columns. For each columns we are getting it. So you can also print mi and also do another thing, which is sort the values. Right? If you want to find the important information, then mi.sort_values based on the values ascending as false. We have done it previously. Okay, so we are not storing it. So this is how we sort the values, and it seems like cholesterol, CP, whole peak, thal, and these columns are very important. And this is how, like, this is not even relevant with that. So that's what the mutual information classifier is giving you. With that, you can select how many important columns you need. You can go, and that's up to you. You can go and select those alone, and then you can go with that, proceed with your algorithm, and then come back and select some like higher columns or lower columns, like that. To select like this, what you can simply do is, instead of going with these complex steps, we'll be using it in the next part mostly, which is select k best. So you can use the select k best and set a value like k equal to 5 here. So that will help you to take the 5 important values. Simple. So you can escape from that burden, right? So to do that, you can take from sklearn.feature_selection, you can import select k best. See the capital and small letters there. You can get the select k best values, and what you can do is you can create directly without going with mutual info classifier. You can create a select equal to an object select k best. The selector is going to pass here. Here, if I pass mutual info classif, that will be used. Later on, what we'll be doing is we'll be using chi-square test, which is chi2. We'll be passing that, and see here for regression I am passing here. So select k best can be used to select based on the score it is giving from your this one mutual info classifier or anything which you pass here. So you have to pass a k value, that much best values will be selected. Using this object you can fit, and then you can get the support, which is going to be boolean. Once again you can filter it. So we'll do this from sklearn.feature_selection, import select k best. Okay, select equal to select k best. I need to pass here we'll go with mutual underscore info underscore classif, k value will be we'll select the important 6 first. Select dot fit x train y train. Now the 6 best have been selected. You can go with select dot get underscore support. Okay, so I'm having, see here, false, false. True means they are important, false means they are not. What you can do is you can pass it as a filter also and get your xtrain.columns. So these are all the important which has been given from your mutual info classifier. You can go and get your 8 best columns. So like that you can select the column. So now if you get the column names, what will you do next? You can choose your xtrain new or selected, it will be equal to xtrain. Okay, get these column names alone. If you pass this also as a filter, that particular columns alone will be selected, right? So that you can store in xtrain new. If you go with the xtrain new, then also remember when you go for x test, once you train your model with this features alone, your testing part will also expect that much number of columns only. So you also need to alter your x test also, then only you can avoid error. Okay, you are just selecting the columns. So if you train with those columns, you have to get answers with those particular columns only. Okay. Okay, 1 minute. Here you need to pass dot columns. That will be stored here. That particular columns now will be there, which can be used for further processing when you go with algorithm. We'll be doing that when we see the project. See here, these are the selected 8 columns which is going to be given for training and testing. So that's all about our mutual info classifier and select k best. Instead of select k best, you can also use this select percentile. Mostly we will be using select k best to select values. If you are confused about how many columns you can choose, 5 or 6, I don't know. If you want, you can use this select percentile. So instead of number of columns, you will go with the percentile, which 20 important percentiles. Okay, remaining will be neglected. How many comes here, that will be selected. Instead, you can go with that. So instead of this, you can call select percentile. Okay, so we'll go and call select equal to, instead of k best, we need to pass percentile. Okay, so here we don't need to pass k, we need to pass the percentile, right? Which is I'll pass 20. Yeah, now you can call select to fit x train and y train. So the importance will be selected here. So select dot get underscore support. So okay, so totally we got 1, 2 and 3 only. If you go with this 20, if you increase it, then we may get some more also. Okay, lot of true here. So with that, you can use this as a filter and you can proceed with the next steps. So that's it with select using a percentile. So for if you have a regression problem, then your y value is going to be a continuous value, right? At that time, you can go with mutual info regression, like a salary prediction or a temperature prediction, or we had that car selling price prediction, right? Those will come under regression. In that, you can use mutual info regression. Moving with the last two, we have chi-square test and F1 over classif test. So going with our chi-square test, it is a statistical test that can be used for feature selection in machine learning. So what this chi-square test will do is, it is commonly used to determine the statistical significance of a features relationship with a target variable in a classification problem. So it's for mostly for classification. So you can use this chi-square test for classification only. And this is going to be once again use a test which is a statistical test, chi-square test, which is going to find the relationship or significance between the feature and the target. Okay, so to achieve this, you can use from feature selection, you can import chi2 and you can pass it in the percentile or select k-best and use it. Once again, you will be passing the k value and select the best columns with that. So from sklearn dot feature underscore selection import chi2 select equal to select k-best. Instead of mutual info, you can pass this and the k values can be passed, and you can call select to fit your x train and y train values. For classification, so here no worries, select dot get underscore support. So like that, you can proceed with that. It will give you the important columns. You can use it as a filter and get the column names. Like that chi-square test, you can also go with ANOVA F test, which is analysis of variance. So how much variance is available, it will calculate between two columns. So it is a statistical method once again used to test the difference in means between two or more groups. So it will calculate their difference, and with that it will try to find how the feature and the target is interrelated. So once again, all these tests are going to determine one thing, which is how that particular column is important for your target. It uses different methods and each method can give different results. You have to go front and back trial and error method to achieve some good results. So it works by comparing and ranking them based on a value which is F score, and to achieve this you can use F underscore class F. So this F underscore class F, you can pass it in the select k-best and fit it and get the support and then proceed further. So that's how we can go with our, instead of this chi2, you can also get F underscore class F. So these are some of the prominent things. Mostly mutual info. For regression you have only that option, right? Mutual info regressor, and here you can use F underscore class F. So these things can be used. See here, this will give somewhat true, sometimes they will be different. See here, this is false here, but here we got true. So like that, something may be interrelated, they can be here, most of them are true, like they are same. So you can go and use this front and back and decide which is good for your particular algorithm. So that's how we'll be proceeding with our feature selection. So we have completed feature selection, and our next task is we know how the steps go, right? We need to learn what is logistic regression, what is the different algorithm name, what it will do when we need to use it. Only when you learn it, you can utilize it. So in our next session, we'll be seeing about algorithms for the next 3 or 4 sessions. We'll see that. Thank you.